Welcome to this tutorial on simulating a conversion reactor in DWSim. In this tutorial, we will learn to define a conversion reaction, simulate a conversion reactor, calculate conversion percentage from conversion function. To record this tutorial, I am using DWSim 5.2 Classic UI and Windows 10. The process demonstrated in this tutorial is identical in other OS also, such as Linux, Mac OS X, or Fossey OS on ARM. To practice this tutorial, you should know to add components to a flowsheet, select thermodynamic packages, add material and energy streams, and specify their properties. The prerequisite tutorials are mentioned on our website. You can access these tutorials and all the associated files from this site. We will develop a flowsheet to determine the exit composition from an isothermal conversion reactor. Here we give reaction, property package, and inlet stream conditions. Next we give reaction parameter and reaction conversion. I have already opened DWSim on my machine. Go to File menu and select New Steady State Simulation. Simulation Configuration Wizard window appears. At the bottom, click on the Next button. Now, in the Compound Search tab, type carbon monoxide. Select carbon monoxide from ChemSafe database. Similarly, add hydrogen. Next, add methanol. And then, at the bottom, click on the Next button. The Property Packages opens. From Available Property Packages list, double-click on Raoult's Law. Then, click on the Next button. We are moved to a new window named Flash Algorithm. From Default Flash Algorithm, select Nested Loops VLE. Click on the Next button. The next option is System of Units. Under System of Units, we will select C5. Then, at the bottom, click on the Finish button. Let us now maximize the simulation window. Now let's insert a feed stream that enters the conversion reactor. On the right hand side of the main simulation window, go to Flowsheet Objects. In the Filter List tab, type Material Stream. From the Displayed list, drag and drop a material stream to the flowsheet. Let's change the name of this stream to Feed. Now, we will specify the feed stream properties. Go to Input Data. Select Flash Spec as temperature and pressure if not already selected. By default, temperature and pressure are already selected as Flash Spec. Change temperature to 320 degrees centigrade and press Enter. Change pressure to 70 bar and press Enter. Change mass flow to 1500 kg per hour and press Enter. Now, let us specify the feed stream compositions. Under Composition, choose the basis as mole fractions if not already selected. By default, mole fractions is already selected as basis. Now, for carbon monoxide, enter the amount as 0.2 and press Enter. For hydrogen, enter 0.8 and press Enter. Similarly, for methanol, enter 0 and press Enter. On the right, click on this green tick to accept changes. Next, we will define the conversion reaction. Under Tools, click on Reactions Manager. Chemical Reactions Manager window opens. Under Chemical Reactions tab, click on the green-colored Add Reaction button. Then click on Conversion. Add New Conversion Reaction window opens. Under Identification, enter the name as Methanol Synthesis. Now, let's enter the description. Synthesis of methanol from carbon monoxide and hydrogen. Next part is a table of components and stoichiometry. The first column, name, shows the available components here. The second column corresponds to its molar weight. The next column is include. Under include, check all the checkboxes. The fourth column is BC. Under BC, check the carbon monoxide checkbox, as conversion is defined in terms of carbon monoxide. Next column is stoichiometric coefficients. Under stoichiometric coefficients column, enter -1 for carbon monoxide, -2 for hydrogen, and 1 for methanol. Then press enter. In the stoichiometry field, we can see it shows OK. So, the reaction is balanced after entering the stoichiometric coefficients. Here, the equation fields shows the reaction equation. Then comes conversion reaction parameters. The base comp is already indicated as carbon monoxide. Select phase as vapor. Now, go to conversion. In a conversion reaction, conversion can be defined in two ways. First, conversion is defined directly as percentage. Suppose it is provided that reactant undergoes 50% conversion. Then we have to enter 50 against conversion. Secondly, conversion can be defined as a function of temperature. As per the problem statement, conversion function is given as 267.45 minus 0.591 into T, where T is in degree Celsius, but in the reaction manager, it can be seen that T is in Kelvin. So, we will modify the function and enter the conversion as 267.45 minus 0.591 into, in bracket, T minus 273.15. This minus 273.15 is to incorporate the change in temperature from Kelvin to degree Celsius. At the bottom, click on OK button. And then close the Chemical Reactions Manager window. Now, let's insert a conversion reactor to the flowsheet. Go to Flowsheet Objects. In the Filter List tab, type Conversion Reactor. Drag and drop it to the flowsheet. Let us now arrange it as required. And name this reactor as Conversion Reactor. Now, let's insert two more material streams that exit the conversion reactor. To do that, let us drag one material stream to the flowsheet. Let us now arrange it. We will leave that stream as unspecified. Then, we will change the name of this stream to vapor product. Next, we will insert another material stream. Let us once again arrange it. Leave that stream as unspecified and name this stream as liquid product. Next, we will insert one energy stream and name this stream as energy. We are now ready to specify the conversion reactor. So, let's click on it. On the left, we can see a tab displaying properties related to conversion reactor. Under Connections, click on the drop-down against Inlet Stream and select Feed. Next, click on the drop-down against Outlet Stream 1 and select Vapor Product. Next, click on the drop-down against Outlet Stream 2 and select Liquid Product. Then, click on the drop-down against Energy Stream and select Energy. Now go to the next section, Calculation Parameters. Here, the first option is Reaction Set. By default, it is default set. Next, click on the drop-down against Calculation Mode and select Isothermic. Now, we will run the simulation. So, from the toolbar, click on the Solve Flowsheet button. When the calculations are completed, click on the Conversion Reactor in the flowsheet. Go to the Property Editor window of the Conversion Reactor. Locate Results section. Under the Reactions tab, check Conversion. It is 78.33%. This is the conversion of the base component of the reaction. In this case, it is conversion of carbon monoxide. Now, go to Conversions tab. We will look into the individual conversion of all the reactants. Here, for carbon monoxide, the conversion is 78.33%, and for hydrogen, it is 39.16%. Now, go to Insert menu and select Master Property Table. Double-click on the Master Property Table. Configure Master Property Table window opens. Enter name as Stream-wise Results. Enter object type as Material Stream. By default, Material Stream is already selected, so we will not change it. Under Properties to display, select object as Feed, Vapor Product, and Liquid Product. Under Property, scroll down to see all the parameters. Now, select the properties as Temperature, Pressure, Mass Flow, Molar Flow, Molar Fraction Mixture, Carbon Monoxide, Molar Flow Mixture, Carbon Monoxide, Molar Fraction Mixture, Hydrogen, Molar Flow Mixture, Hydrogen, Molar Fraction Mixture, Methanol, Molar Flow Mixture, Methanol. Let's close this window. Move the Master Property Table for better visibility. Here, we can see the corresponding results for Vapor Product, Liquid Product, and Feed. The reaction is a vapor phase reaction, so we can see that liquid product stream shows zero flow rate and composition. Let's summarize. In this tutorial, we have learned to define a conversion reaction, simulate a conversion reactor, calculate conversion percentage from conversion function. As an assignment, repeat this simulation with different compounds and different conversion, different property package, different feed conditions. Was the video available at the following link? It summarizes the spoken tutorial project. The spoken tutorial project team conduct workshops and give certificates. For more details, please write to us. Please post your time queries in this forum. The FOSSEE team coordinates conversion of existing flowsheets into DWSIM. We give honorarium and certificates. For more details, please visit this site. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificates. For more details, please visit this site. The FOSSEE team helps migrate commercial simulator labs to DWSIM. We give honorarium and certificates. For more details, please visit this site. Spoken Tutorial and Fossee projects are funded by NMEICT MHRD, Government of India. This tutorial is contributed by Kaushik Datta and Priyam Nayak. Thanks for joining.